Welcome everybody to linuxacademy.com. My name is Terry, and in today's course we continue our preparation for the Linux Foundation Certified System Administration exam. In today's video we're going to be talking about how to assemble disks on our system as a logical volume group. Now, a logical volume group is one or more disks that appear to the file system, the underlying file system, to be contiguous space. And that simply means that I could have under one partition, one mount, 5 different disks or 2 different disks or 3 different disks that combine all of their space in whatever way we assemble that space together into a referenced logical volume group so that we can continue to expand or contract the file system size as needed. So in our case, what we're going to do, let's go ahead and start up our terminal, and let's look at the disks that we have available on our system. If we do, let's go ahead and become root. All these commands need to be run with sudo privileges or as the root user. And let's just do an fdisk-l. And what we'll see is that we have our SDA partition, which is our root, our swap, and our boot drive. We'll see that we have SDB with no partitioning, about 8 gigabytes, SDC, 8 gigabytes, SDD, 8 gigabytes. And then we've got the Docker mapper, which doesn't apply to this particular video. So what we've got is we've got 3 disks, 8 gigabytes in size that we can work with. Well, the first thing that we have to do, which we've done in more detail in a previous video, is to fdisk or prepare partitions for those videos or for those disks so that we can use them in a logical volume group, but we have to indicate that they're logical volume managed drives. So the first thing that we'll want to do, again, if we do an fdisk-l, make sure that we're picking the right disks. So we've got SDB, SDC, SDD, and we can double check that none of those are mounted with a df-h and see that only SDA drives are mounted as well as the CD-ROM. Go ahead and clear this. And we'll start with an fdisk on dev SDB. Now right now there's nothing there, and if we look at by printing out the partition table, there's nothing there. So we want to create a new partition. We want it to be primary, and we only want one partition. We're going to leave it as the default full size for that particular disk. But in this case, whereas in the past all we've done is written and then formatted the drive, we want to give it a type. So that's a new command, that's a T, and then we can do an L to list those commands. And you'll see what we're looking for here is Linux LVM, and that should be and has been in the past 8E. So if we take a look and try to find 8E here, it is indeed right here. So 8E is Linux logical volume managed type. So that's what we're going to do. We're going to do 8E, and then we'll do a P, and it says that dev SDB1, which is 8 gigabytes in size, is a Linux LVM. And then we're going to write that to the partition disk, and then we're going to repeat that for each of the other ones. So SDC, we're going to do new primary 1, enter for the size, the type is 8E, and then we'll write it out. And then for SDD we will do the same thing. New primary 1 default type 8E. And when we write it out, now what we should see if we do an fdisk-l is now we see that we have 3 drives that are partitioned with a single partition each, 8 gigabytes in size, all listed as Linux LVM disks. Now we have to prepare our new partitions for the logical volume manager, and we use a utility called pvcreate. So we're going to do a pvcreate and then the partitions that we want to use, SDB1, SDC1, and SDD1. And what this will do is it will create the logical volume assembly for these 3 drives. So now the physical volumes for each of those partitions have been created. And if we wanted to remove that, we could do a PV remove, dev SDB1, dev SDC1, and dev SDD1 if we made a mistake, and make sure that if you've added them as a group that you remove them as a group, because all it's doing is creating these volume labels so that we know that they're logical volume managed disks. So we're going to go ahead and recreate those. We'll clear the screen. And now all we're going to do is we're going to take a look at what that result will look like by doing PV display. And what this does is it says the physical volumes of each of these have these characteristics. So their dev SDB1 is 8 gigabytes. It has a UUID, SDC1, and SDD1 as well. So that's really the current state of our volume managed LVM disks. But now we need to create what's called a volume group. So we're going to create a volume group and give it a name that we want to refer to these particular disks by. Let's go ahead and clear our screen. And we want to do a VG create, a volume group create, and then we'll call it my volumes. And then we're going to give it the disks that we want to include, SDB1 and SDC1 and dev SDD1. In fact, we can go ahead and leave one of them off. Let's create a volume group called My Volumes, and you'll see why we're doing this here in a moment. So we're creating a volume group called My Volumes. Now if I do a VG display, remember PV display for the physical view and VG display for the volume group view, I've got My Volumes, LVM2, and it's 16 gigabytes in space. And the volume group has a UUID that's associated with it. We can also use a different command to learn information about our volume groups by doing a VG scan. And what it does is it reads all the physical volumes and it determines whether any volume groups exist from within those physical volumes. Now, if I wanted to, I could rename my volume group by doing a VG rename. So let's go ahead and do that just for grins. Let's do a VG rename. And then all we need to do is tell it what the old name was, which was My Volumes. And we'll call this one My Data Volumes. And then if we do a VG scan or a VG display, we'll see that I now have a volume group name of My Data Volumes. Now remember, at this point, we've taken 2 of the 3 disks that we have available, and we've created a 16 gig volume group from, we have 24 gigabytes available. But what we want to do now is we want to create our logical volume itself so that we can actually access the disk. Then what we need to do is we'll take a look at how do we add the third disk to the volume group and expand the file system. So let's use a command called lv create, and we're going to pass in a name. So let's do lv create -- name, and we'll call it first group. So that first group is going to be built off of, we could do -- size and give it a certain amount of space from the 16 gigabytes from the volume group that we have. But in this case, we're just going to -- name first group from My Data Volumes. -- size 16 gig. $16 gig was a little bit bigger than the file system that we had created, so we passed in 15 times 1024. So the logical volume first group was then created. So now that we have that logical volume group, we can do an LV display. So again, we've been working our way down the list: PV display, VG display, LV display. And if we do an LV display, we can see that I have dev my data volumes first group is a 15 gigabyte file system that's available. The LV status is available, so the logical volume status is right now available. And again, if I do an LV scan, it'll tell me that that particular drive is active. But you'll notice that right now, nothing has been mounted. So let's go ahead and clear that. Now we could rename the volume group from an LV perspective, but in this case, we're not going to. We could also remove it using an LV remove and then recreate it. But what we want to do is we want to enlarge the file system using the additional disk that we have. But first, let's go ahead and mount the file system so that we can go ahead and use and mount the file system itself. So we have these logical volumes. We don't have any file systems, and without a file system, we can't save anything. So let's go ahead and create an ext3 file system and get it mounted. So if we do a LV scan, we know that dev my data volumes and first group is actually what I'm going to format. So instead of using dev SDB, SDC, SDD, I'm going to format them as a group because that's how they're combined. So if I do an mkfs-t ext3, I'm actually going to be formatting dev my data volumes first group. And now, if I wanted to, if I go to the mount directory, let's use the temp directory, making sure nothing's already mounted there. TMP, nothing is mounted. So I can do a mount -t ext3. And if I do an LV scan, so I have it right in front of me, -t ext3 dev my data volumes first group to mount temp. Now, if I do a df-h, I see that dev mapper my data volumes first group, which is how it appears as a volume managed group, a logical volume manager, to the mnt temp directory. So now I have this file system that contains 2 disks in it that is 16 gigabytes in size. But I've got this third disk that is outside of that volume group. So how can I add that disk to my volume group so that I can expand the file system? So the first thing that we would do normally is we would go ahead and create the group, or we would create the partition as LVM, and then we would do a PV create on the dev SDB, or in this case SDD1 device. We've done that already, so we have, if we look at our system, we can do a VG display, and that tells us that we have the 16 gig, but if we do an fdisk-l, we know that we've got this third disk, dev SDC, or SDD, that currently is not added to any particular group, SDD1. So we want to make sure when we're going to extend a file system that file system isn't mounted. So the first thing that we want to do is if we do a df-h, we need to do a umount on the temp directory. And then just make sure that file system is no longer mounted. Can't extend a volume if the file system is not mounted. So let's just do a VG display. We have our 16 gig disk. And now what we want to do is we want to extend the volume group, my data volumes, with the device that we are going to use for the additional space. So if we do a VG extend, and then the volume name, so the volume group name is my data volumes, and then the device that contains the partition that we're going to add to that particular volume group, and spell VG extend correctly. And it says volume group my data volumes is successfully extended. And now if we do a VG display, it should tell us that it's about 24 gigabytes in size. So we want to make sure that whatever we extend it by, we have 15 gig now, we'll extend it just by 8, and we'll leave that additional space available to us. If we do a PV scan, we'll see that I now have these logical volumes available to me. And then we do an LV display, which will tell me that my logical volume group is actually only 15 gigabytes. So now my volume group has been extended. Now I need to extend my logical volume group, and I just do exactly the same thing. But I do it by an LV extend, and then I have to give it the dev name, which is dev my data volumes and first group, and then the device dev SDD1, and then the size of the logical volume is changed from 15 gig to 23 gig, and the logical volume first group has successfully been resized. However, if we run a df command to see if there's available disk space by rerunning it, we'll see that it hasn't changed yet, because we need to resize the file system using the file system resize command so that it's appropriately recognized. So again, as root or as sudo, we do a resize to fs. Now let's do a LV display here so that I have the name here. And we'll do a resize to fs dev my data volumes and first group, which should then complete the resizing on the file system. We'll need to run e2 fsck-f on dev my data volumes first group, and then resize the file system. So the E2FSCK is simply a file system check, and if you get that message, just simply run the fix on the E2FSCK because it's a journaled file system. That just simply means that there's either a problem with the partition or the file system groupings or the reference counts, etc. And E2FSCK will check that extended file system. And then, as you can see, we've been able to resize the file system. Now, if we do a mount on -t ext3 on dev my data volumes first group on the temp directory and df-h, we'll see that we now have my data volumes first group is now a 23 gig file system because we extended it by the 8 gigs on the third drive that we have on our system. So it's a process of taking multiple disks into a volume group named as a particular collection, extended and combined together, and then created logical volume sets within that also have a name and become a device reference. And then you can extend it by simply adding a device to the volume group, then adding that device to the logical volume group, checking the file system, and running the resize to fs command. This is how we assemble all these disks, disparate disks, into one larger file system that can be expanded on demand. So for assembling disks into an LVM file system, that's all there is to it. My name is Terry for Linux Academy.